So, stargazing, observing the deep sky, what's it all about? Well, I suppose the first thing we ought to get absolutely clear is what actually is the deep sky. And it is everything that is outside the solar system. So it's everything except planets, moons, sun, and comets and asteroids, or what, in really helpful for anybody who doesn't know what's going on in there, the official term is SSSBs, small solar system bodies, which is astronomers speak for comets, and what you know as comets and asteroids. So not those things. So there are loads of things inside the Milky Way galaxy, which is our galaxy, our neck of the woods. It's this approximate disc-shaped collection of stars and planets and all the other things we'll be hearing about, containing about 300,000 million stars, give or take 100,000 million. I mean, it's very difficult to know precisely how much, but it contains stars, asterisms, which we'll look at, which are informal groups of stars, star clusters, nebulae, which are basically fuzzy patches. The word means clouds. We tend to just call them fuzzy blobs in astronomy. There's lots of different kinds of fuzzy blobs, and if you start getting into deep sky observing, you will have a relationship with fuzzy blobs. And then outside the Milky Way galaxy, there are other galaxies. So these are the sorts of things we can look at. Now, there's lots of levels you can get involved in this. You can get involved just for pleasure, and there's absolutely nothing wrong with that. Or you can get involved to a level where you're actually contributing to science. One of the lovely things about being an amateur astronomer is you have got kit which you can use when you want to. You don't have to apply for telescope time if you've got your own. You can quite often take it to where you want to as well. And so you have a certain flexibility that the professionals don't have. And there are some things, and I'm going to concentrate to some extent on things called variable stars, where the professionals are extremely reliant on the work that simple amateurs like us do. So what we're going to look at is the first three levels of equipment that you might have and what you can do with what you've got. The obvious first one is your unaided eye. This is the equipment, we say, that astronomers have used for almost the entire history of astronomy. It's only since the 17th century that we've had optical aid for doing this. And enormous advances were made without any optical aid whatsoever. Next level up, and this is something I'm quite keen on helping people get involved with, is handheld binoculars. Binoculars you could use for any other purpose as well. And lots of households have those, so you actually have the kit you need. And they can enhance, as we'll see, what you can do with a naked eye. And then lastly, either a telescope or very large mounted binoculars or binoscopes. We're not going to go beyond that. I'll mention imaging a little bit at the end, but that is really beyond the scope of this talk, and I can give you an idea where to go if you want to get involved in imaging. So, unaided eye. What sort of things can we see with it? Well, you can do what people have done for thousands, tens of thousands of years. You can observe the changing constellations throughout the year. If you're going to do that, what I suggest is, you go out every few weeks on a nice clear night. Apparently it's a nice clear night out there tonight, and sketch what you see. If you sketch stuff, you actually have to look carefully to do so. And by doing that, you will start to get to learn, if you're new to this, you'll get to learn how things change from day to day. I mean, it's a 4-minute change a day, which isn't a lot, but that over the course of a month is a 2-hour change. So going out every few weeks, you'll see how things have changed. Things that were due south of you are suddenly over to the west. And then they get lost and new things are available. So this is one thing you can do, and gives you a really good basic familiarity with the sky. You can learn some prominent large asterisms. Asterisms, I'll show you some in a moment, are these informal groups of stars, things that might look like other things, but also learn how to use them to find different other things as well. Once you start recognizing them, you can start using them as jumping off points to find things that you might be slightly more interested in. And I'll be showing you some of those. You can do things like record the color and the changing brightness of some stars. Some stars change in brightness, some stars change in color. For the unaided eye, there's not a lot of color change visible, but certainly changing in brightness, absolutely. And some of these stars which change in brightness, by learning how they do it, by collecting data on how they do it, you are contributing to real astronomical science. And this is something that is not particularly difficult, although I have to put my hand up in advance and say, I'm pretty blooming awful at it. I don't know why, because I've always had exceptionally good night vision, but when it comes to what's called variable star observations, I've always been completely rubbish at it. So let's have a look at some asterisms. So this is the northern sky as it would be if you went outside round about the end of this talk. And the things that you might pick up that you see, there's the Big Dipper shape here in Ursa Major, which lots of people recognize. The pole star we've got in the center here. This is the bit that it's always directly above the north point on the horizon. And then other constellations around it. Ones we're going to be a bit interested in this evening are Cassiopeia, which is like a W on its side at the moment, but these rotate around here. So sometimes Cassiopeia will look like a W, sometimes it'll look like it does there. When it's over here, it'll look like a backwards 3, and so on. And Cepheus or Cepheus here, in particular, we're going to have a look at this star over here, because this one is a very, very interesting star. And we'll look at it in relationship to another couple, but that's to come down the lane. So these are called asterisms, these informal groups, which are not the actual constellations, some of which we're going to look at. So the Big Dipper, you've probably heard of, a dipper being like a ladle or a spoon. That's actually an American term for it. In Britain, it was generally known as a plow. So you'd hitch your horses on here, the ground would be going along here, and this is the plow here, and the plowboy or plowman would be behind there, and we pulled that way. To the ancient Greeks, this was actually a wagon. Again, horses here, you stand in there. But it's also, the whole thing here is the Great Bear. And then you've got the Little Dipper over here. And one of the things you will learn as you get into astronomy is these two stars here actually point to the pole star. And that gives you a good sense of orientation of what's going on around here. So we're going to look at around here. Got a little kite up there. It's called Kemble's kite. It's a little kite-shaped, little diamond kite with its tail up there. We won't worry too much about what's here, but this W, the W of Cassiopeia, is important, and we'll use that for jumping off to other things as well. Honoris Frederici, or Frederick's glory, it was a later creation. It's essentially a baton with vine leaves around it. It's the way it's presented. Sorry, not vine leaves, laurel leaves around it. It's presented, but it's one of the historical things for Duke Frederick. So these are things that we could look at, but we have these asterisms all over the sky. Now, if you get Stellarium, which is what this is from, this is a free app for Windows, for Mac OS, and for Linux. you can set this to any date, time, place, anywhere in the world, and there is an option to get it to show the asterisms. And they're good things to start off with. Okay, let's move on from there. The other thing that's great with the unaided eye is the larger, what are called open clusters. These are associations of stars. They were generally born out of the same, what's called a molecular cloud. And they're still mostly gravitationally loosely attracted to each other. So this over here is the Pleiades, the Seven Sisters. Depending on how good your eyesight is, you might see anywhere between 6 and 10. Of course, coming to somewhere like Cranborne Chase, nice dark space there, you've got more chance of seeing more. Just to the left of these are, if you know the song Green Grows the Rushes, these are the April rainers. This gradually moving west more and more, 4 minutes more every day, and it will come to a time when you can just see it before it sets, before it gets lost in the dusk twilight. And when that happens, that's around about the beginning of April, and it begins the April showers might be imminent. So from that song Green Grows the Rushes over, that 8 for the April rainers, that's this lot here. So you see a lot of astronomy is tied up with culture and legend and folklore and, trying to relate what's going on in the sky with what's going on the ground. There's also a little cluster here, which most people don't recognize. It's quite interesting to the naked eye. It's obviously, most of these things we'll see can be a lot better with some sort of optical aid. But this is called the Mesa cluster here, and it's very nice. That's the star Betelgeuse, or Betelgeuse, if you want, over there. So these are things you can see, look at them, get to know them. And certainly, last night we were out observing at Coombe Bissett, and lots of people asking, what is that? It looks so beautiful there, and that's just with the naked eye. We can also, would you believe, see a galaxy, something that's 2.5 million light years away. If you're not quite sure how light years work, well, a light year is the distance light travels in a year. Now, in a second, it'll go 7.5 times around the Earth at the equator. Light from the sun takes 8 minutes and 19 seconds to get here. What we're going to look at, which you can see, again, people were looking at it last night with the naked eye, is one of our companion galaxies. So what you do, so we go to this Cassiopeia, this W, which we've got some of it showing here, and you take this arrowhead here, and that arrowhead points down to a yellow star here. It's distinctly yellow. And then at the moment, you can try this tonight, to the right of that is a fainter white star. And exactly the same distance further on is the galaxy. If you look at this star over here, but concentrate your attention here, or your gaze over here, you'll see it more easily. It's a technique called averted vision. And you are now you'll see that as a little fuzzy smudge. It won't be as distinct as it's shown here. And that is probably the most distant thing most people will ever see with the naked eye. All the other stuff that you can see is within 100,000 light years of us. This is 2.5 million light years away. If you want to get a feel of what that means, the light that you see when you see that left even before we were Australopithecus or anything like that. This is a long, long time ago. There's another little fuzzy smudge, same distance approximately the other side of the star here, over here, which is one we'll look at later. It is possible to see it with a naked eye under very exceptional conditions, but don't expect to do that. Most people won't. Okay, so you can see outside the galaxy there. But I said we want to concentrate on variable stars. Lots of stars vary in brightness, and the first one that was noticed was actually a star that we're not going to talk about tonight, but it's called Mira, for miraculous. It's a star that in the constellation of the whale, Cetus, that every now and again it suddenly brightens up, and that was deemed miraculous. It's a very reddish star, and it's a particular class of red giant star. But there's another class of star, and one of them is called Algol or Beta Persei. So it's in the constellation of Perseus. You can use Stellarium to show you exactly where this is. Algol, which is Arabic for the ghoul, the demon, is traditionally, it's the evil eye of the Medusa that Perseus took. Perseus took the Medusa's head to turn the sea monster into rock. But every 69 hours, and this is why it's called the demon star, it dims for about 9.5 hours. What you've actually got is you've got two stars in orbit round their common center of mass. And when the fainter one comes in front, this is in line of sight with us, it blocks the light from the brighter one and it just blinks out. So this is something that you can see, and it's actually very dramatic when it starts happening. You will notice that the dimming effect takes about 30 minutes. You can actually watch what happens as a star appears to vary in brightness. Now, if you want to know where it is, this is a standard chart, sort of chart you would use. The bright cluster of stars in Perseus is here. The W of Cassiopeia is over here, and Algol is down there. But I use Stellarium to help you find it and have a good look at it. Get to know it. It's actually fun to watch that happen, particularly if you're showing people and you're maybe out with friends. You say, look, that star, watch that. We'll come back and look at that in half an hour's time or something, and people see it's gone. That's one. But another brilliant one, one other one I told you to look out for earlier. I pointed out 3 stars. There's this one here, which is called Delta Cephei. It's what's named a whole class of stars called a Cepheid variable. Now, this one is not just 69 hours. This one varies over about five days and about 8 and a bit hours. And it doesn't vary quite so much, but it's a very special sort of star because the rate at which it varies depends on its intrinsic brightness. So what that means is all you have to do is measure the period of variability, how long it takes, and you know how bright this star is in itself. Now, obviously, when stars are further away, they look dimmer. But if you know how bright a star actually is, or you know how bright it looks, you can work away how far it is. So this is one of the things people use to get a distance scale in the universe. So people look at these stars in distant galaxies, for example. That looks that bright, but actually we know it's that bright, therefore it's that far away. You never use one of these things. They're called standard candles. But the way you do it with this, and this is something this is where you can start contributing to science. It actually varies between the brightness of these 2 stars here. Don't worry about the Greek letters are, they're called Bayer letters. It's just a way of identifying stars, that you just pick them up from a star chart. So this is zeta, this is epsilon. And so what you would do is you'd go out every clear night for a while, and you'd just sort of judge its brightness. Is it as bright as zeta? Is it just slightly fainter than zeta? Is it between zeta and epsilon? Or is it just only slightly brighter than epsilon? Or is it as faint as epsilon? And by doing that, you can plot what's called a light curve. Now, this particular star is very well known, but this is something you can do with the naked eye. And this whole technique of comparing a variable star with stars of known brightness is something that is extremely useful and is something that professional astronomers are very grateful when amateurs do it. So something you can simply do with the naked eye is something that can actually aid professional astronomy. We'll come back to that in a little bit later. Okay, so the next step up is binoculars. What I'm showing there is 10 by 50 binoculars. 10 by 50 binoculars are really the sort of the workhorse of handheld binoculars in amateur astronomy. They've got enough aperture, that's the 50, and so the aperture in millimeters of the big end here, and the 10 is the magnification. They've got enough aperture to gather a lot more light. So this will gather approximately 100 times more light than your eye will. But the magnification isn't so bright that your shake is magnified so much. So you can, with a little bit of practice, handhold these quite steadily. And they're very, very useful. So I think of them as, well, they're sort of unaided eye plus. Going from unaided eye to something that's magnifying 10 times, it's relatively easy to get, translate the scale from what you've learned with your unaided eye to the scale of what you're seeing in the magnified view, and necessarily smaller field of view. And the other nice thing about binoculars is, if you do lose interest in astronomy, you can use them for so many other things. Just a bit of a hint: when you're using binoculars for astronomy, do not put the binoculars to eye, then start casting around. What you should do is look at whatever it is, the area of sky you want to look at, and then just lift the binoculars and put them in the way, as it were. And if you can't see what you think you were looking at, you're probably too low, so go upwards. So in addition to what we can see with the naked eye, we can see bright nebulae, these bright fuzzy patches, dark nebulae, the dark fuzzy patches, things called globular clusters, and things called planetary nebulae. And so let's have a look at some of that, but also look at how it enhances what we could see with the naked eye. So this is an asterism. This is one in the constellation which nobody knows, called Camelopardalis, which means the giraffe. And this is a group of stars called Kemble's Cascade. It's called Kemble after a Canadian astronomer, Lucien Kemble, found this in small binoculars and started showing it to people. And what it is this straight line of stars, bright one in the middle, with this little star cluster at the bottom. Now, in autumn evenings in Northern Hemisphere, this is just about vertical. And so you can imagine it as a little ribbon waterfall with the splash pool at the bottom. And it really is delightful, and it fits nicely in the field of view of 10 by 50 binoculars. If you're helping friends or youngsters get interested in astronomy, this is one of the lovely things to show them. A friend of mine showed this to me when I first came to the Northern Hemisphere, Bob Meisen. He said, well, it's actually, think of it as a wristwatch. You've got the strap and the watch itself and the other bit going on. You can use your imagination to make it whatever you want to. These pictures that different traditions have seen in the sky, it's all to do with imagination. This one, it's called Eddie's Coaster. It's actually named for a chap who was, unfortunately, he died 2 years ago, Eddie Carpenter, Cotswold Astronomical Society. He discovered this. Nobody else had noticed it before. The W of Cassiopeia, that's the middle star there. The rest of it's sort of over here and over here. And it's not obvious on star charts, it's not obvious anywhere, but it's obvious in 10 by 50 binoculars. And it's like a roller coaster of stars. And so there's your little roller coaster in the sky. That's Eddie's Coaster. This is a mixture of an asterism and an open cluster. So this whole thing here is an open cluster, a gravitationally bound, but loosely bound group of stars that all formed out of the same molecular cloud, which is known as Colander 399 or Al-Sufi's cluster, and has a few other common names as well. But in it, there's a coat hanger in the sky. And that sort of usually brings a smile to people's faces if you're, again, sharing the sky with other people. But if you're going for open clusters, particularly at this time of year, this is the one you must go for. I've mentioned the Pleiades already. This is them. The Pleiades, the unaided eye said you'll see anywhere between about 6 and 10, depending on how good your eyesight is. On a good night, with 10 by 50 binoculars, you will find it difficult to count them. You'll get up to at least 40 and then you'll lose count and have to start again. The easiest way, actually, if you do want to try and count stars in something like this, is to draw what you see, and then you can count them in the drawing afterwards. You can sort of section the drawing up a little bit, but draw what you see. You don't have to do it white on black. Most astronomical drawing is done the other way around. The biggest problem with drawing and sketching in these islands is the dew that makes your paper wet, but you know, a little bit of ingenuity you can get around that. So this is the Seven Sisters, and you can see it is not 7 anymore. We'll come back to this because one of the things I want to show you is how some things, looking at them with binoculars, is actually much, much more pleasurable than looking at them with a powerful telescope. This is another open cluster. I call it the cluster that everybody's seen and nobody knows. These are the 3 stars of Orion's belt. Most people look at that because what they want to get to, something again I'll show you later, is the Orion Nebula, which is sort of would be down off screen. But if you look at this in 10 by 50 binoculars, it is stunning. There's this beautiful, beautiful, beautiful cluster of stars around here, these wonderful chains. I mean, just look at this here. This is almost like it's a swan's head and neck going down here, coming up to the swan's wing there, you know, sort of swimming through this. And these, again, these stars are gravitationally bound. This one here isn't actually, it's not part of it, but you look at them, they're very bright blue, almost bluey white stars. They're very young, hot stars. And so you can start learning your way around the sky and learning to look at things like this. I could spend 20 minutes on this and start seeing something new every time. You know, you look at it and you say, oh, I've only noticed that little group over there. I didn't really notice that before. And this is a really good exercise, looking at something and seeing how much more you can see, because actually teaching yourself to look rather than just sort of, sort of there, just sort of, yeah, you can see it, but you don't really pay attention to it, is really, really important. And you can, by doing this, you can learn to see so much more in the sky. Now, this is another one. This is, find on your star chart the constellation of Leo, and behind it is the constellation of Coma Berenices, which means Berenice's hair. To the naked eye, this looks like a little misty patch, but with binoculars, you see it resolves into stars. And this has been known for, well, a very long time. The legend of Berenice was she was a queen of Egypt who said she would sacrifice her hair if her husband came back safe from battle, which she did, but to honor her fidelity and all the rest of it, Zeus took her hair and threw it into the sky, where it is to remind us all this day, which is one story of it. But if you know your Shakespeare, there's in Midsummer Night's Dream, there's the play within a play with the rude mechanicals, the Pyramus and Thisbe, which is actually taken from one of Ovid's books, the Metamorphosis. It's actually a Babylonian folk tale. And this is not Berenice's hair. This is Thisbe's veil, which she dropped when she got frightened by the lion, which is Leo, which is right next to it, which ends in this sort of dramatic or pseudo-dramatic multi-death scene at the end with Pyramus and Thisbe taking each other's lives, taking their own lives because they each thought the other had been killed or knew there was. Anyway, enough of that. Variable stars, which I've already mentioned with the naked eye. I'm not going to go into it with binoculars. The Society for Popular Astronomy, the SPA, which is British, the British Astronomical Association has a variable star section, and you don't have to be American to join the American Association of Variable Star Observers. They all run programs for people with binoculars who want to observe variable stars with binoculars. They will give you a mentor to teach you really how to do it, to really support you on that way. And when you're doing it with binoculars, it's just as I showed you with the unaided eye. You will have a chart, you will find the star, and you will compare the brightness of the star that you're looking at with stars of known brightness. And that is essentially how it's done. It would be I think, slightly tedious to go through, to run through that whole process here. But if you want to contribute to real astronomical science, this is a relatively simple way to get involved. Other things you can see, well, large galaxy. So we've already had a look at the Andromeda galaxy with the naked eye, but you put it in binoculars and you can suddenly see a whole lot more. So you can see it has a little companion galaxy here. It's actually got another little one just in there, just below that star there. You can also, on most relatively transparent nights in the UK, you can see that the light drops off gradually on one side of it and more abruptly on the other side. What you're actually doing is detecting the dust lane on the near side. And if you've got not only incredibly good transparency, but incredible stability, what is known as seeing, you can sometimes just get a hint of another little dust lane in there. Now, this is with, sort of binoculars that have cost you less than 100 quid. There's a lot you can do, and you can get enormous pleasure from this. I mentioned the galaxy, the other side of the bright star that was pointed at from Cassiopeia, and that is this one. And that is really not that impressive at all. But it's actually easier to see in 10 by 50 binoculars than any cheapo telescope that you might buy, costing round about the same. Binoculars offer you a really good way into deep sky observing. One of the things I do actually is I write a free binocular astronomy newsletter every month, just to help people who are getting involved in binocular observation. Right, dark nebulae. Now, these are the dark patches in the sky. We'll have a look at some later as well. This you won't see at the moment. You'll have to wait for summer to see this. This is a star cloud right in the southern Milky Way, the bit of the Milky Way down near the horizon that we see in the summer. And you've got these dark patches in it. And these dark patches, for many, probably thousands of years, people thought there were voids in the sky. It's actually where there was there were no stars. We now know this is not true at all. This is not voids in the sky. This is foreground dust, mostly carbon, stuff that's already been through stars, and as stars have created the dust that has formed this. So this is actually foreground dust, which is blocking our view of the stars. If you look at a region of sky like this with an infrared telescope, which you can from space, you see there are many more stars in here, and they're shining, but their light, as most of the visible light, has come out, but the infrared still coming through. But and you have these all over the Milky Way galaxy, but the easiest place to start looking for them is down in these summer star clouds, the very dense part of the Milky Way that you get in summer. And then you can see the Milky Way then arching overhead, and you'll start to pick them out there as well. They're just rather beautiful. In the southern hemisphere, dark nebulae, these dusty things, are actually a lot of the tradition of that. There's the Great Emu in Australia, which is actually a huge dark nebula running down the center of the Milky Way that they see there. It's their emu in the sky. There are things called globular clusters. This looks completely unimpressive. What it looks like is an out of focus star. I'm going to leave it there for a moment. You can see them, you can detect them in binoculars, but actually you need a little bit more. But if you think that's unimpressive, how about that? This is the thing we're looking at. It's called a planetary nebula. It's actually the result of a star about the size of the sun coming to the end of its life, and the core collapses to form something that's called a white dwarf, and it throws off its outer atmosphere, and that's it. This is the second biggest one that you can see from the UK. The biggest one is quite low down in the south, and it's quite difficult to see, but this one's actually, so this one, even though it's tiny, is easier to see. If you look very, very carefully at that, you might see that it's actually either side here. It's sort of nipped in the middle a little bit in the waist. Well, have a look at that. It's called the Dumbbell Nebula. You can detect these things with binoculars. You're not going to see a heck of a lot of detail. To start seeing detail on the small stuff, you obviously need to magnify it more. To magnify it more, you need more aperture. And there are two routes to this. The route I prefer is big binoculars. I really like my big binos. These ones here are ones I've had now for over 20 years, and they're probably my, well, no, not probably, they are my most used observing instrument by some stretch. The sort of things they cost a bit to start with, but the amount I've used them, I'm down to like single number of pence an hour for it, which is, I think, really good value for money. They are lovely to use. We had them out last night at the dark sky event we were doing at Coombe Bissett, and lots of people are enjoying the views through those. The other thing is get a telescope. This is a Skywatcher Classic 200p. We have these at the AONB actually for use for events as well. And this is your workhorse telescope. It's a telescope that is good for a heck of a lot of things. It's a good general purpose thing. It's incredibly simple to use. It's just up and down, and then it rotates on this base here. So to use it, you have to be able to find your way around the sky. But that's something that's worth learning. And if you spend the best part of a year just learning your way around the sky, all of a sudden it does become incredibly easy to do. And this has got an 8-inch aperture and will show you, it's also actually, I say, very good for planets, but it will show you stuff that is very, very much fainter than a lot of other things. And you can change the eyepiece here, so you can change your magnification. If you magnify too high, everything goes dim. So you can find the optimum magnification between something that is, get big, having it big enough to be able to see some detail, but not so dim as you can't see anything. And that's practice. And then you think you've got it, and sky conditions change, and you haven't, and it goes back there. It's a continuous learning process. I mean, I've been doing this for, actually, it's frightening. It's nearly 65 years, and I'm still learning loads. It's a lovely thing about astronomy. You never stop learning. So I see these as sort of like binoculars plus, in the same way as binoculars I saw as unaided eye plus. Telescopes, binoscopes are binoculars plus. But you have to be careful, because there's lots of things that actually don't fit in the field of view anymore. So here is our 10 by 50 binoculars view of the Pleiades. This is the Binoscope view here. You can see, well, yeah, you can see that little bit, sometimes known as Ali's braid, going down there. It's the same as that bit there, and you can see more stars, but actually it's lost, I think, a lot of its beauty. And then you look at it in a bigger telescope where you're magnifying, well, those stars there or those ones there, you can't see what it is anymore. You've lost the glory of it, you've lost the beauty of it. So unless you're doing something scientific with these, you need to watch it. But what they can show you is something absolutely stunning. So this is the view of the Orion Nebula, this a star-forming region in Orion's sword. I can spend 20 minutes, 30 minutes looking at this, and the more you look at it, the more detail you see in this. And it's actually the reason I got my big binoculars. I'm looking through somebody else, and I thought I just got to have some of those. So I started saving up for them. It's absolutely glorious sight. Never tire of it. And I've been looking at it through big binos for about 25 years now. The galaxy we were looking at, you can see so much more going on now, can't you? Notice it's also the other way up, because telescopes tend to flip things the other way up. So you've got the companion galaxy here. You can clearly see the cutoff from the dust lane here and where the core is and all that. So you're starting to be able to see much, much more detail. Your globular cluster, which in here in the binocular view is pretty boring. It's your defocused star thing. You look at that in a decent telescope, and that's what you've got. You've got this cluster of hundreds of thousands of stars. And these are actually quite important, again, in the same way as your Cepheid variable star, which is you can work out its actual brightness. Globular clusters are used for the same thing, because if we assume that all galaxies formed in the same way, then you can make a general assumption that globular clusters, the brightest ones, are in one galaxy about as bright as the other. So you can see how bright it is, you can guess how bright it looks, and you can figure out how far away things are. Getting a distance scale was one of the 100 years ago was a big problem in astronomy. But this is one of the ways they did it. You never use one of these things, by the way. You always try and get at least three things that complement each other, just in case you've got an outlier somewhere. Our planetary nebula, which looked pretty blooming boring in binoculars, you put that into a telescope, and now doesn't that look so much more impressive? Okay, this would be through not that, it'd probably be a slightly bigger telescope than that. This is simulated view of what I see, and I have a 16-inch aperture telescope, and that's about what we'd see there. So each level you go, you can see more and more detail, but you see less and less of the generality. And it's really a case of finding, if you're doing it for pleasure, what suits you. And I would say really either go for 10 by 50 binos. If you're going to go up to a telescope, go for something like that 8-inch Dobsonian telescope, the 200p Classic, something like that. It's an absolute workhorse. I actually made one myself many years ago, and I eventually sold it to buy some glass to make something else. And I really miss it. So I'm in the process of making another 8-inch telescope now because I miss it so much. Okay. That's generally about as much as you see it. You notice in all of this stuff, we haven't seen colors. And that is because these things are actually quite faint. And in order to trigger the color sensors in our eye, you need a lot more light intensity. Now, our eyes do not accumulate photons. So really, if you want to see colors, you really have to get into imaging. Imaging is the way to show colors. This horribly overexposed is something I took with a 14mm focal length lens. And this is, actually, you wouldn't recognize it. It's horribly overexposed. It's part of the sky we've been looking at. So there's the Andromeda galaxy there. Those are the two stars that led your way to it. That's the other galaxy around there, M33. Here's where Perseus is. There's Kemble's Cascade there. And if you look carefully over here, you can see, oh yeah, here's the W of Cassiopeia. Not very distinct at all. You're actually losing all the detail in the sky, but that's the bit when we had the arrow pointing down to that star there, and we jump across there. So there's loads you can see in something like this, and you get the colors of things. You get the colors of stars. So I say that's horribly overexposed. You can look at other regions of sky. This one I took a couple of years ago with a longer focal length lens. We see here, so I'm using a lens 135mm. And here we can start seeing things like the dark nebulae. We can see, and it's actually called the North America Nebula. You can either think of this as being, well, this is Gulf of Mexico, so we've got Mexico down here, Florida here, that's the rest of North America. Or you can be Canadian and think, well, that's Hudson's Bay up at the north there, and then, you know, the rest of the United States is down this way. It doesn't really matter. It's called the North American Nebula, or NGC 7000 as we've got here. And you can also see in here lots of little star clusters as well. And it's a way of getting to know this. As I say, it's beyond the remit of this talk, but if you are interested in getting into astrophotography, we will be uploading, I think, the workshop we had on that on Tuesday evening, from Mary McIntyre, who's a wonderful teacher of astrophotography, and she will take you through the basics using really very, very inexpensive equipment, and show you. That will show you how you can get things like this. So this is, I say, this is just an introduction to what you can do. I hope you found it at least useful as an introduction. If you've got any questions that we can't answer tonight, or you want to talk about, what kit can you buy or something like that with the finances you have available, jot down my email address, which is on the screen now, and I will do my best. I'll say there's no such thing as a silly question, so don't worry about that, and I will do my damnedest not to give you a silly answer. So thank you for listening, and I hope it's been useful, and I hope it's been interesting. So let's move on from that.
Brilliant. Thank you, Steve, very much indeed. Blimey, I've learned a lot tonight as well. I've got a couple of questions that cropped up. One is about the Binoscope. Is there a particular make that you might, I know there are others available, but, is there a particular one that you might suggest? And kind of, you hinted they cost a bit, about how much?
Right. Well, how much they cost is like saying how long is a piece of string. You can pick up a pretty basic 100mm aperture binocular for round about 250, 300 pounds. You can go up to 3,000 pounds on that. And if you think that's expensive, I'm sorry, you're being a cheapskate. Astronomers are notorious cheapskates when it comes to binoculars. Birders, on the other hand, are not. So for a 10 by 50 binocular, the sort of thing that I would say, spend 100 quid on, a birder will go for a 10 by 50 binocular that costs 2.5 grand. And yeah, they are fantastic, but well, they really are fantastic. Things like Swarovskis, the really good 10 by 50 astronomical binoculars will cost you 7 grand, but that's again, it's something you're not going to start. You're not going to start out like that. I would recommend, if you're starting out on handheld binoculars, there's a thing called an Opticron Oregon 10 by 50 WA. The WA stands for wide angle. It's like, I reviewed this for Sky at Night Mag a year ago. And what I said in the review, and I still hold by it, is like somebody has been listening to what us reviewers have been saying for years about what we want in an entry-level 10 by 50 binocular, and actually implemented it. It's they're about 65 quid. They are incredible value for money, I think. So very good for that.
Okay. The others, you said, the sort of really big boys that you had a picture of.
Yeah. Okay. Well, the ones I've got a picture of aren't made anymore, but you can get them secondhand. They're called Miyuchi. But APM, which now I think one of the things we need to understand is nowadays most of these stuff are made in the same factory in China. It's a place called United Optics in Kunming, in China. But they are specified and branded by different organizations. APM, which is a German binocular seller, do exceptionally good quality ones, as do Explore Scientific. So those are worth looking at. And in England, similar ones are sold by an outfit called Altair Astro, but you can get these. So something like those binoculars I had are probably going to set you back, depending on which ones you get, anywhere between £1,500 and £3,000 now. So unless you're sure this is for you, it's probably not sensible to spend that amount, because you will also need to spend money on mounting them. There's absolutely no point in getting a really good optical instrument and then skimping on mounting it, because what you're doing is hobbling it, and that really doesn't make a lot of sense. So you do need to spend on a mount as well. The mount I use is a thing called a parallelogram mount. I've mounted on a surveyor's tripod because they are robust, and you tread them 3 inches into the ground and they're not going to move. But the parallelogram mount is something you can set it up. I can look at something, I can have it for my height, and I can just drop the parallelogram, and a child can see exactly the same thing, because even though I've dropped it, it's still pointing at exactly the same thing. So they are wonderful, wonderful for outreach, wonderful for families, doing things with families and that. Sometimes you might need a step or something as well.
Okay, that's great, Steve. I've got two more for you. Three possibly. Somebody's asked, are the image stabilizing binoculars worth the high price?
This is, of course, it depends on what you want. The image stabilizing binoculars are absolutely incredible. The ones to go for, really, I think the best image stabilized systems are the Canon, and the more recent Canon are the ones they use the same stabilization system as they do on their high-end image stabilized lenses. Now, I've had had a few of these to review actually, and they're a joy. What I've done with these is I've held them up to my eyes. I've tensed my arms so the binoculars shake like mad, and you have this weird thing of the sky that you see is absolutely rock solid with the binoculars shaking around them. You can see, I would say, with the 10 by 30 image stabilized, you can see as much as you can with 10 by 50 mounted binoculars. So they're very good for that. So if your need is for something that is small and portable, that's great. The thing is, the binoculars I use, what I call my portable binoculars, actually 16 by 70s, and I put them on a monopod. I can see more with that setup than I can with image stabilized binoculars costing 3 times as much. Now, at the moment, while I'm still capable of doing that, to me, it makes sense to not have image stabilized. But the moment I can no longer do that anymore, or the moment the portability of something much smaller kicks in, I will have no doubt about going for image stabilized binoculars. It's an astonishingly good technology, but look at the prices. The good ones for astronomy are the best ones, I think, are the Canon 42 ones, and they are 42 mil ones. They are because they're the only ones that are waterproof. Now, I know we don't do astronomy in the rain, but we get a hell of a lot of dew, so you want to stop dew ingress in that. They are astonishingly good, but they don't come cheap. So it's a matter of what is your priority.
Okay, thank you, Steve. I have one more related to your talk this evening. It was from earlier on where you made the comment that it may help to make a sketch of what you see. Now, the question is, should I perhaps use a red light to help me do that sketch and to see the sketch paper, or is there some other trick?
No, absolutely right. And it's something I probably should have said. Yes, use red light. Red light doesn't damage as long as it's dim, it doesn't damage your dark adaptation as much. It will damage it very, very slightly. So, but yes, sketching under red light. As you're getting older and you get presbyopia in your eyes, you might find that you actually need spectacles as well to see it, because red light doesn't focus the same as most of the rest of the spectrum. But the best way is to try it and see whether you need your specs if you wear them or not. But yes, definitely red light. Otherwise, you will just damage your dark adaptation, and you won't see what you're looking at. But that sketching is brilliant for learning how things are, because you just got to look. And by putting it down, you're learning it.